Hi everyone, I'm Ed Blanchard-Wrigglesworth, and today I'm going to talk about the Antarctic heatwave of March of 2022 and its characteristics and attribution. And this is work that I have done with Tyler Cox and Zach Espinosa in atmospheric sciences at the University of Washington, and also with Aaron Donohoe at APL, also at the University of Washington. This figure I show you here on the bottom left is a time series of surface air temperatures from Dome C. Dome C, also known as Concordia, is a research station in East Antarctica shown on the map on the right. And the time series shows the daily air temperatures at the station between 1996 and 2021 in gray, and in 2022 in blue, while also showing the daily climatology in black. And there are three remarkable aspects of the heat wave that I want to highlight. And you can see the heat wave quite clearly. It's that blue spike you can see around day of year 80, which is mid-March. And during this heat wave, there was a temperature anomaly of 39 degrees Celsius above the climatology. This is the warmest temperature ever recorded at Dome C, even beating the summer maxima, during which time the climatology is 30 degrees warmer. And it also, the other remarkable aspect is that it beat the previous March record by 16 degrees Celsius. Now, we have found using both station data and the reanalysis that this is the largest positive temperature anomaly ever recorded. So in essence, the biggest heat wave measured as a local temperature anomaly. And here we show maps of the largest temperature anomalies at every station, and that's shown by the dots, and also at every grid cell shown by the shaded color in reanalysis. And we have found that the largest temperature anomalies always take place in high latitudes during the winter. So that's why we only show poleward of 50 degrees in both of these panels. And on the right, you can see the sort of that red hotspot in East Antarctica, and the red dot that corresponds to the March 22 heat wave. Now we have found, looking at the dynamics of the atmosphere, that the heat wave resulted from a strong atmospheric ridge. On the left, I show you daily 500 hectopascal heights in contours and the surface temperature anomalies. And these are shown every day from 14th of March up to the 18th of March, which is when the heat wave peaked. And there are two things I want to highlight. One is you can see that the temperature anomalies sort of build up in place. They're not advected from elsewhere. So you can see how that sort of red hotspot sort of builds up between the 15th and the 16th and the 17th, all the way to the 18th of March. And at the same time, it's accompanied by a ridge. And you can see that in the contours, how between the 14th and the 15th and the 16th, we have what we call an omega block in the atmospheric circulation, bringing very strong northerly, warm and moist winds. On the panels on the right, I show what we called a back trajectory analysis, which shows where the air parcels are coming from. And these are shown on the 17th of March and the 18th of March. And these are basically backtracking air parcels from Dome C. And we find that 4 days before, that air was over Australia. So this was basically an Australian air mass that was transported into the interior of East Antarctica by these strong northerly winds. Finally, we have investigated what the impact of climate change on this heat wave is, and we have done this using a climate model by replicating the observed heat wave in the model, and we do that by nudging the winds in the model to observations. And what we've then done, the second step, is to run the same simulation, but under the current climate, and that is shown on the left in the red time series, under a past climate shown in the blue time series, and under a future climate shown in the orange time series. And you can see that, you know, these three distributions are sort of offset, which is what we expect. The heat wave is well simulated. You can see that by the spike in temperatures. And we can see on the panel on the right, that is the difference between the distributions on the left. We can see that the heat wave was made 2 degrees warmer by climate change, and future heat waves will be about 8 degrees warmer than an early 20th century heat wave. Thank you.